Now, can I do the same thing for constant pressure? Starting from the same equation that I have. Ooh, do you guys want to try that on your own? What? It's the exact same step. Well,
I'm saying I'm still writing notes here.
Okay, I will stay quiet for a minute. Keep going.
You can keep talking. It's just I'm gonna.
So for the constant, we just divide by pressure.
It will be divided by pressure, but we have to do a little bit more than that because we need CP. So remember, this one has a CV in it. Now I need a CP. So how do I go? How do I go from a CV to a CP?
Plus R.
Plus R.
Yep.
So how do I involve that in this problem? You already know. Woohoo! Okay, well, don't tell anyone. Not yet. Then are you good?
You can
Okay,
going.
I'm gonna keep going.
I'm always behind.
That's okay. You're not behind. We'll catch up. So I'm gonna start from the same equation that I had for quantity. So I can do all the same steps as I did before. And I can get to this part. I'm being a little bit lazy. May I rewrite this equation here? NCV dt over T plus nRT over V dV over T equals delta S. Da, 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 da. Okay, so again, the T's will go away. We know that. But I have a CV, which is for constant volume pressure, for constant volume situations. I now need a P in my equation. How do I do that? I know this is for an ideal gas. What do I know about an ideal gas? PV equals nRT. Am I allowed to differentiate this equation? Nobody yelled at me, so I'm going to do it anyway. Gwen agrees. Gwen, we're doing it. Okay. Let's go. What will be the answer? PdV plus VdP equals nRdt. Am I allowed to divide the whole thing with PV? Okay. So I'm going to divide by PV, divide by PV, divide by PV. Do I get dV over P plus dP over P equals nR over PV dt? May I also write dV over, oh, sorry, that should be V. Huh. Nobody caught me on that. Over V as nR over PV dt minus dP over P. This is dV over V in that equation. Am I allowed to plug this value of dV into here? Calling this the flower equation. We had a bumblebee, so now there's a flower.
Didn't we have a flower before?
We did have a flower before, but that was a different one. I think that was a tulip.
This one should be a lizard.
Okay, fine. This is going to be a lizard. Wait, how did you draw the lizard?
Draw a triangle for the head, like a diamond, and then a diamond for the
Wasn't
body.
it like that?
Well, that's a good way to do it.
There we go.
Outstanding. You're saying outstanding.
That's the
See?
one. I showed you that one.
Yeah.
Okay, so what does the lizard equation become?
Snake with legs.
Snake with, shush. It's the best lizard I've ever drawn. This is the first lizard I've ever drawn. So that would be NCV dt over T plus NR over PV dt minus dP over P equals delta S. So now since this is dt on this side, may I rewrite this as NCV dt over T plus NR dt over t minus nr dp over p equals delta S. Did you guys see how I did that? Do you know why I did that? Excellent. Thank you. PV equals nRT. So PV over nRT is T. So 1 over T is PV over nR. With me so far? Excellent. Can I combine these two to give me, drum roll, do we get how we got that?
Yes, we don't know.
Minus nRdP over P delta S. Ooh, I have something similar to what I had before. I have a term that only depends on T. I have a term that only depends on P. What do? Take a wild guess. Ooh, from what to what? Excellent. Term 1, initial will be over what state property? And what about term 2?
Pressure.
There we go. Can you guys do it?
I mean,
You could, but
write
you
it
want me to
down.
do it anyway. I get it.
And it's in our notes, in the collected notes.
Yeah, that's true. From T1 to T final, from P initial to P final, taking logs, coming up with an answer. What will I get? N CP, hold on, T final, T initial, NR log of P final over P initial, delta S. I have 2 blue equations
They're different blues.
Make
in different
one-
blues.
Make one purple.
No, I intentionally made them both blues. Okay, so do you see some similarities between these 2 equations? Andy, that should answer your question. Do you see similarities between the 2 blue equations? They're almost identical, but with a very important difference. Exactly. Do you understand why that is happening? Good. Right? Which should then lead you to the last point. What about for constant temperatures? You have 2 blue equations.
Are we going to get a third?
We are going to get a third, but what do we know about constant temperature equations? So yes, we could do the whole entire thing, right? All of the math. Or we could pick either one of those 2 equations and just put delta T equals 0. Which means T final equals T initial. The T part of either of those goes away. Pick one to do. Which one do you want? Temperature or volume? Pressure or volume? Volume. So that means it will just be delta S equals NCV log of V final over V initial. And it's all